2/5 u to 5/2.
I'm going to get 1/2. Yeah, this would become u to the 5/2. Remember the shortcut? 3 plus 2 is 5 over 2. When I'm integrating, I add. When I take a derivative, I subtract. And in front, it's going to be 2/5. This will be u to the 3/2, and in front would be 2/3 plus c, and then I just distribute the 1/2. So I get 1/5 u to the 5/2 minus 1/3 u to the. I should be putting back in what x is, but too bad for me. And then finally, what was u?
X squared was
Yeah, x squared plus 1. The 5/2, x squared plus 1 to the 3/2. There. How's that? Alright, that averaged out pretty good. I had one horrible, several mehs, and a couple of okay. Alright. So here's where it's going to be a strange thing to say, but here's where things get interesting. When I have somebody help me out, what does that mean by itself, right there, that the integral with the 0 and the 1 on it? What the hell does that mean? No, come on. There's no rate of change in. Sorry, Pablo.
area from 0 to 1.
What does 0 and 1 itself mean?
From the limits. X below.
X axis. Beautiful. That's what the x variable does. So the by the book way of doing u sub when you have limits is to change your limits so that they do what you would do. Not you, but you. Yeah. So here, can you follow along with this? I don't want to. That's obviously the inside function. Is that cool? Yeah. And its derivative is twice, so I put a 1/2, so I could have a 2. Is everybody cool with the first couple steps there? Has nothing to do with the limits. The derivative of this is 2x plus 2. Well, the top would be 2x plus 2 if I had just had a 2 here. Well, how do I put a 2 there legally? 1/2. Put a 1/2 on the front. That's where that red stuff came from. Alright, so that's what we were just doing, because the first step on integration has nothing to do with the limits. You've got to first get the antiderivative and then plug the stuff in. But now, when I apply my substitutions, if u is this, I can figure out what u is when x is 0. When x is 0, u is 6. You see that? Is that cool? Just plug it as 0 in for x. And when x is 1, plug a 1 in, you get 9 for u. So then you change the limits. X goes from 0 to 1 means that u goes from 6 to 9. So that's... Do you guys see that? If I have a u integral, I have to know what the hell u is doing. If I have an x integral, I got to know what x is doing. How we doing? And then you just integrate like normal, and the beautiful thing is you just plug into the u and you'll be done. Right, so I skipped obviously a few simplification steps there, but just adding some fractions. So let me show you a different way to do that same problem. I'd like to start with this nowadays because this is the way the book shows you. I'm going to show you the way that I made for myself. All right. And one reason why I'm okay with doing it this way is because if you're going to Calc 3, is anybody in that boat needs Calc 3? Changing the limits will become really important. There's no way around it then. Because you'll be doing, alright, I'm not going to freak you out. You need to understand how to change limits and so forth. Right? So it's okay. But let me show you an alternate way to do this exact same problem. This is the way that young Jeff did it when he was in class.
How did that last one end up 1/36? Okay.
So if you put 9 in, you get 1/18, right? You get negative 1/18 minus, when you put a 6 in, you get 1/12. Is that cool? Minus negative 1/12. So you get negative 1/18 plus 1/12. 336 minus 236 is 136. Sorry, you should tell me when you can't see what the hell I'm doing. 336 minus 236 is 136, yeah. Cool. You just got to do it to see it happen. Alright. So let me show you an alternate method here. The reason that, so I told you why I'm okay with this method. because you need to count 3. If you're not going to go to count 3, or you want to see something else, here's another way to do it. So let me catch back up with where this is. So I'm at this point here. So here's what I did as a student. And I just told my teacher, I'm like, deal with it. No, I didn't say it. Eventually he succumbed to me because I kept doing it. He's like, all right, shit. And it's not, all right, screw it.
YOLO.
So here we go. 1/2. Now when I do my substitution, du is 2x plus 2dx. That's du. X squared plus 2x plus 6 is u. So I get that, right? So I get that. And what I do is I leave the 0 and the 1. I just put them in parentheses to remind me that that's not what u does. That's what x does. Because what do? At the end, I put things back in terms of x. And then I just plug 0 and 1 in.
That's pretty smart.
Mathematically, it's about the same amount of work, to be honest. But also, to be honest, when you don't have limits, if you use u sub, you have to go back to the x, right? You have to. So it's good to kind of keep that in practice, right? So here it would look like, when you integrate this, what do you get? So remember, this is u to the negative 2.
So it's 1 over u.
Negative, yeah. So it'd be negative 1 over u. From 0 to 1, still in parentheses, because that's what x does. And then I just bring back, so this would be negative 1 over 2 times u, and u was x squared plus 2x plus 6. It's just for me. You still can't see. That's all right.
And then you're
Now I can say from 0. Now I can just plug in 1 and plug in 0. You'll get the same thing. Mathematically, I just did the exact same thing. It's just that I never liked changing the limits for whatever reason. Hopefully you guys can see it's about the same amount of work. So it doesn't really matter which way you do it. You just got to be careful. If you do go further in calculus and you don't have me, and you like this way, you better run it by your teacher so you know what the hell you're doing. Right? They might not like it. Because they might be, if you're going to take out 3, they might be trying to get you ready for the weird-ass limits you got to do in there. And I don't blame you. Okay. Make sure one of those two methods makes sense. So here, try part A here. We did one sort of like this the other day. Just didn't have a square root in it. Good, yeah. Yeah, we're going to do it both ways. So I'm going to use u sub on it, and then we'll do it that way. That's why you always look to see if you can simplify first. Alright guys, let me catch up to you. So what is u going to be? ln x is 1 over x. Is its derivative. It's in there.
Which method are you doing?
I'll start with the by the book method. This method up here. So if u is ln x, du is 1 over x dx, so I can rewrite this as, oh now you got to change those. Alright. So now I'm out of practice. So if so 1 over x dx, I can replace that with du. And I've got 1 over the square root of ln, so that becomes 1 over square root of u. And what do the limits do? Well, if x is e to the fourth, u is the natural log of e to the fourth, which is 4. And if x is e, u is the ln of e, which is 1. So we go from 1 to 4. That's what u does. Cool. So that can... Say it, sorry? Yeah, so I know that u is ln of x. And I know that these are values of x. So I just plug each one in, and I can converting each limit. I can rewrite this as u to the negative 1/2. Stay with me now. And when I integrate that, I get...
So, 1, 2.
Yeah, you know 1/2. Divided by 1/2 says 2. From 1 to 4. Now the only bad thing is, if you change the limits, don't go back to x. I mean, you know, choose one method or the other. You get some funky ass answers. So now I just need 2 times the square root of 4 minus 2 times the square root of 1.
2.
Yeah, you get 4 minus 2, you get 2. Is that right? Did anybody do it the other way? That's fine. That's mine. You don't have to do it. What about part B? I mean, if I did use u sub, what would I let u be? This is a good question. There's another way to do this problem, by the way, if you realize that. But let me just try to show you u sub first. What would you let u be?
Cosine squared.
You wouldn't let u be cosine squared, because, I mean, this is where, this is the same place where you're supposed to get used to this idea of playing around with math. Was in pre-calculus when you had to do the trig identities. You try something like, that didn't work, let me go try something else. You're supposed to be cool with that. You're supposed to realize that's part of the process. So if my first guess is I let u be cosine squared, what do I get when I take its derivative? Bless you.
2 sine x plus sine
2 cosine x
negative sine
times negative sine x. Now is all that shit in there? No. Alright, so my first guess, no good. I mean, it's okay. It doesn't mean that you didn't know what you're doing. It was a good first guess. Good effort. Good try. Yeah. So just a second. We're going to do it the better way in a second. But if I had to do u sub, if the instructions were use u sub on this or get no points, what would I try secondly since cosine squared didn't work? Just cosine. Because cosine is inside like 1 over something squared. That's fine. That's another possible form that something could be inside. And what's du? And isn't there a sign up there waiting for me? I like it. So that would work. So it would look like, alright, screw it. I'm not going to do this. By the way, alright. Sine x dx, and I need a what now? Inside. A negative. So I better put a negative there, so I need a negative out front. Get over there, Jeff. So I need a negative there, so put a negative there to balance it out. Negative sine x dx is du. And cosine squared is now u squared. And that's completely integrable, right? Completely integrable. Now a much better way to do this specific integral, a much better way to do it is to try to simplify it first. Yeah, in fact, we had this exact same thing a couple days ago, I think. Something like this. Is this sine over cosine times 1 over cosine? And this is sort of 0 pi over 3 tangent. And what's 1 over cosine? And I know the antiderivative of that. And so do you. Yeah, secant. Derivative of secant is that. So the antiderivative of that is secant. So just be secant x from 0 to pi over 3.
2.
You would get the same answer if you followed that u sub we started to do. You would get the exact same answer that we're going to get here. She said this was a little quicker. So u sub is one of the easiest processes, but if I don't even need to use it, that's even easier, because then it's just straight up give me the antiderivative. It's a lot quicker then. So what's the secant of pi over 3?
2.
Does everybody agree? You guys out there? So pi over 3 is, again, you got to know your tricks. So cosine likes x, so the closer it is to 0 degrees, the bigger cosine's going to be. So pi over 3 is far away from 0, so it's going to be the smaller. It's going to be 1/2, not root 3 over 2. And then secant, of course, is 1 over that. So that would be 2. And then what's secant of 0?
1.
1.
Can you zoom out?
The other method's on the other shape. Every single one of these, how do you check them? You can just pull up this whole thing in your calculator in Y1. Second calc, number 7.
0.
Put in 0, put in pi divided by 3. Don't approximate it. And it should come out to be 1. It's awesome. You can check every single one of these.
And just to make sure, so du every single time should be on top, right?
Beautiful, exactly. I love it. That is going to come up a few times. You can never... Let me see if I can make one up real quick. Can you, Jeff? I don't know, Jeff. Oh, this would be kind of silly to do this, but just a real quick example. Obviously, what would you do with this?
Divide.
That's right. So break it up, divide, right? Simplify. This is the bottom. It's just one term. But real quick, let's say somebody tried to do this. And they got du is 2x dx. Is that so far? I mean, that's what they've done is right, but it's not the right thing to do, right? But then they say, okay, so I just need a 2 here, and then 2x dx is du. The minute you're trying to put du on the bottom, you are in the wrong direction. It's got to be integral stuffed du. The du can never be on the bottom. The du can't be inside something. Not yet, anyway. So for us, it shouldn't be. So that's an automatic hint that you're doing something wrong. You're looking at something the wrong way. Du can't be something that's on the bottom of stuff. I like it. So every time I've done this, I haven't said it this way yet, but every time I've looked for du, it had to be something that was free to move. Du was 2x dx. Well, here this didn't work. Screw you. But here, the 1 over rad x can move, so that this together became du. It was stuff that was free to move. It was nothing that was stuck on the bottom. 1 over rad x is the thing that I want. It's not stuck anywhere. It's 1 over rad x. It's right there. So you can't put your du in place of something that's on the bottom. You can't have du end up on the bottom. Yes?
And du is like a width, right?
Yes.
So that's why we cannot also divide it, because we multiply it with it.
Yes, it would lose that idea of getting an area when you multiply the height, which is the function, times the width, which is the du dx. So if you put it underneath, it's like, what the hell are you doing? That's not what an integral does. All right, I like it. What the hell are you doing? Okay. What was the other thing I wanted? Oh, cool. Let's do a little bit. Well, let's see. Any questions from 5 before I get a little bit into 6?
Do we have a quiz for that?
Yes. Now it's going to be. Well, let's see. We're going to have this discussion right now. So if we do a quiz tomorrow, you might want to hear me out. If you do a quiz tomorrow, it would be on section 5.3 and 5.4. If we do a quiz on Monday, it'll include substitution rule. All right. So Monday. Let me make sure. How many guys want Monday with an extra section on it?
Does it really matter?
Look at you guys. It's fun. How many guys want it tomorrow with just the 2 sections on it? Oh shit. You gonna vote for both? Kevin's like, dude, give me both. More grades. Shit. You guys are funny. Let me see, was that an option? That was not an option. Right? At least nobody said Trump. Alright, so let's see. So, okay.
Everybody put your heads down.
We'll do Monday. You didn't want any. So you didn't vote either way. You just said none. So your vote basically, you didn't go to the poll. You just stayed home. Yeah. Alright. So Monday is 5-3, 5-4, and then one problem from 5-5. The next test is not for a while, because I don't know if you've heard anything from anyone who's gone through calculus about the a couple sections in chapter 6, volumes of solids of revolution. So, have you ever seen these decorations for like Halloween, whatever that? When I was a little kid, we had one of those, a turkey. When you open it up, it's like this frilly ball thing. I've got one in my office. So if you have a shape, so you can imagine you have a shape, and then you rotate it around. So you end up, this would look like a bundt cake pan. You ever seen a bundt cake pan with this thing in the middle, right? And you're trying to find the volume of that if I did that. So we can use integrals. Because if I find the area of this, I just have to multiply it with the rotation. That was a beautiful rotation. Say again?
What about like?
Okay, I can do that.
Did that say 1 from 5.5?
1 from 5.5, yeah. 1, no.
Iron word.
Mineral, I thought it was like O-R-E. Alright. So anything left over from chapter 5 before we get into 6? Okay, I'll take that as a no. Can somebody turn that light back on? So, the first section in chapter 6 is nothing too freaky yet. For a certain reason, I'm going to start off looking at it a little bit in the way the book looks at it, and then I'm going to explain how there's a simpler way to look at it, but the way it's going to help us with the next couple sections in the book if I do this. So the main idea with what we've been doing so far is if I have a function and I want to go from A to B, and I want to know its area from where to where. What if I say that's this direction, what about this direction? From the what to the what?
What?
If I were to go shade this in, where would I start? If I'm going to shade up, where would I start?
X-axis.
Beautiful, the x-axis up to there, right? So it's this area here, right? Is that cool? Alright, so it's always in relation to the 0 line, to the x-axis, to where y is 0. So it's from 0 to f of x, basically. How we doing? Alright, so that's how we define it. That's where we started our rectangles off at. So now, the new thing that's happening in this section, the one that's a little more generally useful, is what if I had two functions? Oh, Jeff, what do you got? Two functions. And I want to know this area between them. So say this is f of x. Say this is b of x. And I want to know... Oh, I was excited for that. I got 3 colors. Oh my gosh. This area between. So instead of doing rectangles that start on the x-axis and go up, I'm going to do rectangles that start at this function and go up to that function, right? There you go, Jeff. You can go. How tall is that rectangle I just drew? Let's say it's at xi. What's on top though? Careful.
F of the limit.
Oh, I got you. You're right. You said it right. So f of xi minus g of xi. Right, and the book kind of goes through all the technical aspect of this, but it's kind of silly to do that because, for one thing, if this is the area, if this is the integral from a to b of f of x dx, if I bring in a second dude, so I want to know that area, I would just subtract off what? The area below g, right? If I take the area below f and I subtract the area below g, I'm going to end up with the area between f and g. Is that cool? You got it? Now, obviously, what's on top and what's on the bottom changes what your integral might be. You got to be careful. But if I take that whole area minus the area under g, of course, I'm going to be left with the area between f and g. And one little thing I didn't really, there's some properties of integration, but if I have the integral of f minus g, I can split it up to be this. So if I do all the Riemann sums, if I add up all my rectangles, and I do the whole sum of I squared, replace it with blah, 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 and do all that technical crap, you're going to end up with, the sum, the limit. That's going to become the integral of f minus the integral of g. Ooh, nothing major. It's the same thing, just with two separate things that are being subtracted. So it's almost too nice. The only place this is going to be a problem, so let's do one nice, normal, classic problem, and then I'll introduce a little wrinkle into it. And I'm really, really good at that. So let's say f of x is 10 minus 3x squared. G of x is, what you got, Jeff?
Something smaller than that.
2x squared minus 5. And I want to know the area between f and g on the interval -1 to 1. I think that to be safe. Now, normally you'd have to find where these two functions meet, because that would be where one of them, where they switch, right? Whoever was on top and I was on the bottom. If you try to find out where these two meet, what do you end up getting here? So if I get 10, I want to see where this, how do I see where they meet? What would I do? So they meet with each other. What does this function equal to that function? Did I make something that comes out nice? Almost, not really. Yes? Yeah, I did. Sort of. 5x squared equals, add. Alright, there you go. And then x squared equals 3, so x is square root of 3. Plus or minus, right? And isn't that outside of here? So I chose my interval, so I didn't have to worry about that. So the wrinkle I would introduce is, if my interval is bigger than that, you'd have to switch, you'd have to have an integral for one section, and then you have to do plus another integral, and then you have to write them, the correct function on top has to be first. You guys kind of see I have to split up my integral across where they cross. That would be the wrinkle. So here, I'm cool. Whoever's on top first is always on top here. So, who's on top? So just plug a 0 in. And hopefully you guys realize that's a what words facing parabola? Down. So that's going to be down, it's going to be up. So, basically that's going to be the top. At 0, that's 10. At 0, this is -5. I like it. And do you understand that I found where they cross? So at 0, whoever's on top is going to stay on the top across this interval, because they don't cross until outside of that interval. Okay, all right. So how do I do this then? Which function will I put first?
Integration from f of x.
Yeah, I love it. So f has to go first, because he's the bigger dude. Minus, and here's another place where people may, if I do this, what have I done wrong? I just did something wrong. I like it. You got to subtract that function, not just a piece of the function. You got to subtract the whole damn function. So then negative's got to go through. So you get -1 to 1, 15 minus 5x squared. which kind of like I would expect from what I did there, right? And that's nice. Yeah, it depends on the functions they give you. This was just polynomial, so I know they're going to be easy no matter what.
Negative 5x cubed.
Sure, okay. So I get 15x minus 5x cubed over 3